Welcome to NBC's Hidden Library. What at first may seem like a small library in the Nether opens up to a large 3-story building with thousands of bookshelves and intricate redstone contraptions. And this is how it all works. When you click the button, the walls start to open up above, even though you can't see them, to reveal a large line of flying machines that then start flying over the ice to melt it. As more and more wall opens up, more and more machines get released over the ice. Eventually, they will all hit the end and stop. As this final machine hits the end, you'll see blocks filled, and these start to get sent back. And eventually, you'll start to see the walls closing in. As the walls start to close in, you'll see the bookshelves drop, and this table pop up, revealing the full extent of the library hidden behind the walls. If you look back, you can see the final stages of the wall closing, and the library sealing back up. And now let's look into the mechanism with Sirius, who helped us with this build every single step of the way.
Hello.
Just drop into the floor here, you'll see incomprehensible madness. We had to look through this earlier to figure out what everything, because we just forgot.
Yeah.
So this mechanism, what it does is when these bookshelves drop down, this observer pushes a redstone block forward and puts redstone underneath each of these pistons to push the table up above. And as these get pulled back up, it activates the observer again and pulls the redstone block back, filling all these areas back with air and stone just so the pistons are not powered. Now, to send these back up, we had a very unique problem. Since there's a piston right here in the floor that we had to make so there wouldn't be a gap, we had to somehow power that piston. So that's what this circuit back here does. But the thing is, we had to depower it before we pushed the bookshelves back up, otherwise it would not work. So that's what all this is for. This sand gets filled with redstone torch twice, actually. It gets filled with redstone torch, removed, and then filled again. So we basically input 2 piston movements. So it'll actually move up, because for some reason it didn't want to move. And if we look at these pistons around the back that have the redstone block attached to them, we can see that they also power the same tower that happens. And these originally power and depower the redstone tower to push and pull the pistons as well. If we look back above, we can see this slightly cheaty way that we got these things to be able to melt. You can see barriers here. These are used so we can actually melt the things that melt the ceiling that keeps these guys from moving. Let's actually go outside to see, so people can actually see what we're talking about.
Yeah.
Now, this is when us building in the Nether actually came into play, since ice can melt in the Nether, but it doesn't leave water behind. That was very convenient for what we needed to do. So, if you look down here, you can actually see the mechanism that we used. It's just a bunch of flying machines, and if you look here, these pistons get powered up when it's all the way retracted, so we have an actual level floor. Now, if I press this button down here, it should power it up. And this ice represents the ceiling that would actually be here. And you can see that this is the floor looking in from the inside of the hidden part of the library. Now, if we come up here and press this once, you'll see that it powers halfway, which is a weird problem that we had. So we actually have to power it twice to get it to move. And you'll see that when it reaches the bottom, it powers the pistons up, so now we have a floor that we can walk on. So now, Sirius, let's have you try to explain everything that goes on with the wall retraction, because I have no idea what you did in this part.
Alright, so to be honest, I don't fully understand what exactly I've been able to do here. At first of all, it is quite complex, but it's primarily a lot of clone commands, fill commands, and set block commands attached to a lot of repeaters and timings that basically control all of the flying machines here, there, and these two piston extenders. There's another one over there. There's also that piston extender in the middle that also is controlled by this main circuit here, which powers that circuit and the other circuit that is on the other side. Wait,
do you want me to head in and send these guys back so they can actually see what all you did?
Don't send them back yet. First, let's explain how we use only one flying machine that is constantly spawned in. Basically, when this flying machine retracts, we have another flying machine built right here. We run a few /clone commands, and that takes this flying machine and clones it to that wall right there. Over on the other side, we have another flying machine built. We run another clone command over there, and that spawns a flying machine right here after this flying machine is retracted. This main circuit runs this circuit, which is what pulls back the flying machines on both sides, and this circuit right here is what causes the flying machines to go back. This is what I'm calling the catch mechanism, which is what stops the flying machines from just continuously flying in that direction, or that direction on that side. We've got a simple redstone lamp mechanism here that when pressed will power all 4 of the redstone lamps, causing the observers to get updated. And
that's a relic from when we were testing this. It doesn't do anything anymore.
Oh no, it still does. I still use it.
It's supposed to do, but like it's not going to be useful when everything is back, because it will break everything.
Yeah, it still is used for the initial send off of that first flying machine. So yeah, basically that'll power the 4 redstone lamps, which sends back that first flying machine. These command blocks place obsidian right in front of every single flying machine, so that when one flying machine arrives, a piece of obsidian is placed there, which allows us to stop the flying machine without it damaging the flying machine that was here before it, while also allowing us to send back those flying machines. So when we run the circuit to send all the flying machines back, we can just run this circuit here and break all of the obsidian that these command blocks have placed, and that'll cause everything to get sent back. We have barriers in place that will cause these walls to get stopped when they hit the barriers, cause the flying machine to stop, and then we run a /fill command, which will just destroy the flying machine completely. Again, we don't need to worry about running out of flying machines or anything like that, because everything is just cloned. Once we break all the flying machines and that final flying machine is sent back to here, then the circuit ends and the walls inside are retracted, revealing the entirety of the library. There are also these ice melters right here, which are on the same circuit, this one right here, that these flying machines are activated by. This is all timed so that once this first flying machine starts retracting, these flying machines right here, these two, are sent in as soon as it gets to about right there. Once it retracts fully, and when I say fully, I mean to around here, allowing the second flying machine to begin retracting, these 2 flying machines, this one and this one, will get sent in to melt the ice. The ice melting flying machines operate in pairs, so these 2 are a pair, this one and this one are a pair, this one and this one are a pair, and so on and so on and so on. the easiness reason for doing it that way is so that we have a symmetrical system for melting the ice. There's no ice that's going to block any flying machines, and also just because it's going to look good. This is the first thing that's going to get retracted as soon as we begin the
No, it isn't actually. No, it isn't.
the
Those first two flying machines get retracted one block, and then that
oh
falls
yeah
away.
yeah these two flying machines get retracted, and then this middle section gets pulled back. That is also controlled by some /fill commands. We just have redstone blocks there, and another one up here, and another one here. None of these flying machines here can go until this piston extender is fully retracted, otherwise we are going to break the entire mechanism.
That's not fun. We've had it happen multiple times while we were testing this. It was not fun to replace it.
It's really not fun. Now, if we were to do something where this flying machine fails to retract for some reason, but because everything is operated by multiple circuits, where that circuit gets activated running these flying machines, but these flying machines aren't dependent on that circuit, then these flying machines would still fly out even if this flying machine was still there. And in that scenario, everything would break. And as Tristawesomeness has said, yeah, that's not fun.
Luckily, the way we set this up, it shouldn't happen.
Yeah.
Because if that thing isn't moving, then something else has gone wrong. Shouldn't send out the other flying machines, I'm pretty sure. I'm fairly certain this thing is pretty reliable. I don't think anything should break.
Yeah, it is incredibly reliable. We've tested it at least 6 consecutive times, pulling it back, immediately sending it back, pulling it back, sending it back, so on, so on, so on. And every single time it's been successful with absolutely no hiccups, especially with these ice melting machines, which have to melt the ice and then immediately move forward. However, as soon as they hit any ice, they're immediately going to break. And the way that we achieve them being so reliable at melting ice is by setting the game tick to a very, very high number. When this system when this system activates, one of the very first commands that is run by one of these command blocks, I forgot which one, is setting the game random tick speed to 1200. Normally we'd set it to around 100 or 200 or so that's a huge increase, but as a result it means that every single time this flying machine moves forward, it is going to melt all of the ice in its immediate vicinity, and that allows it to be so reliable. So Tristawesomeness, if you'd activate this, please.
Okay, let me do that real quick.
So these fly machines get activated and immediately start retracting, and these two melting machines fly forward immediately followed by these two, one there and one there. Now these are going to melt the ice, and then we immediately clone another flying machine over here, and that's going to fly back while these ice melters come in. Now let's go and follow these flying machines are retracting the wall. As you can see, we've just spawned in another one that's retracting another segment of wall, and these are going to fly all the way back to this catch mechanism. As you can see, we've spawned in some obsidian there, and more obsidian, and all of the flying machines are now catched. We've also got these double piston extenders over here. These are going to extend and retract this segment of wall, allowing this flying machine to enter, along with that one over there. Now all of these are going to get over here, and then we're immediately going to spawn in some obsidian, which activates all of these flying machines, causing them to fly back. At the same time, we're also going to begin activating these flying machines after these clear the wall, which will extend the wall back into its original position. As you can see, we don't activate the flying machines one by one when we send them back like we did when we were retracting them. We activate them all at once. This is because it's easiest to just send, and fastest to just send them all at once and then fill them as soon as they arrive at a certain spot. And as you can see, we have the final two flying machines arriving in position, and just like that, the entire operation is complete and the system is reset and ready for its next run. The double piston extenders are extended, the wall is completely intact, and all the ice melters are in position. Obviously, there's a bunch of stuff that we have left out because we want to keep our videos in a fairly short time frame, and I don't necessarily want to edit an hour-long video, but we still hope that you enjoyed this a lot. Thank you for watching, and we will see you next time. Goodbye.